Hi guys, my name is Sebastian Fuentes.
And I'm Wendell Akers.
Today we will be showcasing our data analytics presentation regarding drug abuse during the COVID-19 pandemic. Starting with our introduction, this project deals with data collected from the CDC and various hospital records regarding COVID-19 and drug abuse patients. This data analysis aimed to display statistics throughout the years of 2019 to 2021, examining the correlation of how the COVID-19 influenced the use of various types of drugs. For some background, first identified in December 2019 in Wuhan, China, COVID-19 is an infectious disease caused by a newly discovered virus called coronavirus. It has since spread to become a global pandemic throughout the year of 2020. During the COVID-19 pandemic, people were asked to stay at home and limit their interactions with others in order to slow the spread of the virus. By staying at home and limiting their interactions with others, people were able to reduce their risk of being exposed to the virus, but at the same time, it encouraged people to cope with the stress and boredom through the use of substances. For the data collection and cleaning, we decided to use the CDC official site. Since our project was focused on health, drugs, and COVID-19, we chose to start with a reputable website owned by the Federal Agency of the United States. We also came across the Our World in Data website as we were scoping for coronavirus data, and we realized that it was a very trustworthy data website used by many colleges such as Harvard, Stanford, Berkeley, etc. The modules we used for cleaning were request, JSON, pandas, beautiful soup, date, time, and NumPy. As you can see from our code on the right, we decided to take a section regarding race using beautiful soup from a table having to do with respondent characteristics and the prevalence of adverse mental health outcomes and increased substances used to cope with stress or emotions related to the COVID-19 pandemic in order to create one of our insights. In the bottom code, we took data from our World in Data to transfer hospital records into a CSV file and then convert it into a pandas data frame. We did this by filling the data frame and replacing empty data with zeros and including relevant columns that we needed.
So, for this part of the data collection and cleaning, on the left, as you can see, I'm importing values from a table where has the number of overdose and drug deaths over the years from 2015 to 2022. And I had to reorganize each month within the data frame because they were all together, and I had to separate each year with the months and reconcatenate them together so that all the months and years were in the correct order for us to visualize the data accurately. And for the right, I use JSON normalize to actually get the JSON code and then convert it into a data frame. And then I drop the nulls within the data frames. And then I made sure that there was no extra characters within the start time columns because they had extra times that would just conflict with what we wanted to do with the data. So in our first insight, we take the data frames, we take the data frame and we separate it between each age group. So from 0 to 15, 16 to 34, 35 to 54, and 55 plus. And then we wanted to see the average percent of groups who were admitted in the hospital for any type of drug. And what we found was that it increases linearly from the average of 0 to 15-year-olds, 16 to 34-year-olds, and so on. For Insight 2, we wanted to see the percent change of drug overdoses from 2020 to the end of 21. And this insight helps us understand the differences between the amount of drug overdoses before and after COVID. So we could pick up on a correlation between going into quarantine at the start of the COVID period and the increase of drug usage throughout isolation. And the third insight, we wanted to show that the different genders and how they were admitted in the hospital for their respective for drugs. And we're interested in this information because we want to uncover how different the populations reacted to the pandemic and how drastic the difference is. And we'll actually see the results in a data frame later with a visualization. For Insight 4, this was a broad insight. We just basically wanted to see how many people actually received COVID in the US. And it shows how big the effect of COVID was in the United States, and it forced a large population to stay inside for quarantine. And with that, quarantine is one of the main reasons that encourage people to indulge in bad habits like the use of substances and etc. So as you can see in this visualization, we took the number of drug overdose deaths over 7 years, and we also displayed when the start of the COVID period or isolation was. And as you can see, it was beginning to bottom out, and then it shot up. It spiked insanely after everyone came and went into isolation. So this can infer that maybe some people prefer to use drugs or substances to cope with their newfound freedom from school or whatever. And it just opened the possibility to indulge in drug abuse. So this visualization also plays into that. It's a pie chart of the reported anxiety and depressive episodes that people had for the survey that we pulled during COVID. And this, we find that people of color have a higher average of resorting to drugs to cope with stress over the COVID period from the Insight 5. And this can also tell us about systematic problems within the U.S., where some people have access to drugs more than another race, and they're more liable to indulge within it. And for visualization in Insight 3, as I said earlier, you can see all the patients that indulged in substances, and you could see the average percent of the patients and what they were diagnosed for. The average drug use percentage of female and hospital patients were visualized, and as you can see from the data, men have a greater average percentage of admittance compared to women.
So for our conclusion and results, the most important skill that was taken away from this project was our increased knowledge of Plotly and how it works with data frame objects. For example, we had a halt in our project because a column of the VSRR data frame was listed as a string and it was affecting our graph. The use of different modules also played a part in our newfound learnings, and like outside of the use of these different modules outside of class was also a pivotal part of our cleaning, because there was barely indulged in our full capabilities of Python and its library of useful modules.